Ah. Okay, so today is the 7th. We already looked in our warm-up a little bit at matching some real-life situations to graphs, so that was kind of covered in the warm-up, which if you were not here for the lesson, it looked like this. This is from your textbook. It's the first one at the beginning of Unit 4. Then we're going to talk about explaining a real-life situation when we have a graph, talking about what the graph actually represents. We're going to make a graph of information given in a table, and then we're going to be doing a matching activity where you're going to match tables, graphs, and equations. Okay, so the first objective, which is actually our second objective, is explaining a real-life situation given its graph. So we have a graph that shows air in a balloon. Along the x-axis, we have time. The x-axis is always what's called our independent variable. That's the thing that we have control over, or that just happens. Like time just goes on. We can't influence time. So independent is time. The independent variable is always on the x-axis. The dependent variable is the y-axis, which is volume. The volume, or the amount of air in the balloon, depends on how much time has passed. So if something is dependent, it depends on something else, or its value is directly related to what the independent variable is doing. So the dependent variable changes in response to how much time has passed. So what do you think is going on? We have a graph that goes up, it levels out, it goes up, it levels out, up, levels out, up, and then it has a sharp drop down. Can anyone say what might be going on with that balloon?
It's getting caught in a tree. Then
It
letting go
popped.
again.
It
popped.
Okay, wait a second, we have a good idea here. It popped. Which part of the graph shows that it popped?
The
The top.
Yeah, so right here, the balloon popped.
Or maybe somebody shot it.
Something happened so that the volume in the balloon suddenly was gone. Okay, so it popped. Whether that was the result of just popping or someone shooting it, we don't know. What about here? Wait, raise your hand if you know, so it's not random. Travis?
Someone blew air into it.
Okay, so someone's blowing air into it. Why is it a zigzag line though? Why not just straight?
It's losing air. And then
Okay, Adam, try.
Because they're taking breath in between.
Yeah, they're taking a breath. So it goes up, then it doesn't actually lose air there.
Take a breath. Go
It
up.
stays the same, right? Guys, don't talk. It stays the same for a while because the person's taking a breath. Goes up some more when they blow. They take a breath. They blow. They take a breath. They're in the middle of blowing that last breath, and it pops. Okay? Okay, now let's go on with this part. I want you to discuss with a partner, either someone right next to you or beside you or behind you, what are the variables in each graph. So which is independent, which is dependent, and what's happening in each picture. Garrett, tell me what you think is going on in the board length graph.
The board is getting cut.
Okay, which part of the graph shows that the board is getting cut? The horizontal or the vertical? So this part, so the board's getting cut along here. Then what happens here?
They take a break.
Okay, so it's saying that the length of the board is staying exactly the same for a while, and then all of a sudden the length of the board is dropping.
I mixed them up, yeah.
Yeah, so these vertical ones are where it's actually getting cut. Maybe the person is actually sawing along the horizontal, but then this is where the board finally breaks free, and now it's a shorter length. Maybe the person starts sawing some more or takes a break, then the board gets cut. Sawing, gets cut, and then nothing else happens. We can't tell from the graph, but probably it just stays at this length after that.
See that last thing that he talked about?
Adam, what do you think is happening? What do you think is happening with the cell phone cost?
Cell phone costs going up, you on your phone too much, you went over the limit, now it's going up.
Okay, you went over the limit. Good. Good. So you know how whenever you have like so much data, you just pay like a flat rate and you get so much data per month. So this is actually minutes of calls. Nobody that I know of pays for minutes of calls anymore. Most of the time that's all rolled in, but you pay for data. So the cost is staying the same as long as you stay within your limits. Then when you go out of your limits, the cost goes up. What is the independent variable? Let's go back to the board. Seth, which one is independent?
Time.
Time. So this is independent. Which one is dependent then? Paige? Length.
So smart.
Okay, what about for the cell phone cost? Travis, which one is independent? It's got to be the minutes because it's on the x-axis, and then dependent would be cost.
Good job, Travis.
Okay, let's look at objective 3. To make a graph of information that's already given to you in a table. And in some cases, you have to actually finish filling out the table. So we have drinks at the fair cost $2.50. This is represented by the equation y equals 2.5x. Does yours actually say 2.5x?
No, it says 2x.
Change it, it should say 2.5x. That was an error and I didn't remember if these were the old ones or the new ones. So it should say 2.5x, where x represents the number of drinks purchased, so that's defining our variable for us, and y represents the total amount spent. Complete the table, then use the table to draw a graph. So if we buy one drink,
It's $7.50.
that's going to cost $2.50. If we buy 2 drinks, it's going to cost $5. Sweet. Oh, he's not here. Paige, if we buy 3 drinks, how much is that going to cost?
$7.50.
Good. Please only answer if you are the person I have called.
Hey, you have another one of these?
Kaylee.
Hey, Travis needs one.
Okay.
$10. Pass it back.
That's
Wrong
$10.
paper. $10. $10.
All right, $10.
Then it's $12.50.
What about if you buy 5 drinks? Austin, how much would that cost?
Do say 50.
We need to add $2.50 to the 10. $12.50.
Do say 50.
DSC.
Okay.
No, it's do say.
So the equation we already have.
We're talking numbers.
The equation was y equals 2.5x. We filled out the table. Now we're going to create a graph. So this graph is numbered for us. Sometimes we have to put the numbers in the graph, which we'll look at on the next one. So for one drink, they spent $2.50. So that's going to be not quite halfway between 2 and 4. It's going to be a fourth of the way up. For 2 drinks, they spent $5. Wait, I can't see this. There we go. That's where 5 would be. 3 drinks is $7.50. 4 drinks is $10. And 5 drinks is $12.50. So if we were to connect the dots, we would have a straight line, but I'm actually not going to connect the dots because what I'm talking about is the number of drinks, and you can't buy 1.5 drinks. You can only buy whole number amounts of drinks. So I'm not going to connect the dots. This is what's called discrete data as opposed to continuous data, meaning it doesn't just continue. We can't count the amounts in between the dots. There are just distinct answers. Okay. We also need to label our graph. The x-axis, I should have done this first, is the number of drinks purchased. And then the y-axis is the amount spent. Okay, let's look at another example. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? Now, I could actually pick either one to be the independent variable because the other one could depend upon that. I'm going to pick Carrie's age since Carrie is older. I know, Carrie's younger. I'm sorry, Carrie's younger. So I'm going to put her first.
Wait, you put this in this side?
On the left side, I'm gonna put Carrie's age, that's gonna be my X. Kim's age is gonna be my Y. Okay, so when Carrie was born, so let's say she's 0 because it's her birthday. So she's born that day. How old is Kim? Elliot.
0.
2.
2. She would be 2. When Carrie is 1, Kaylee, how old would Kim be? 3. When Carrie is 2, Delaney, how old would Kim be? 4. When Carrie is 3, Brent, how old would Kim be?
5.
And when Carrie is 4, Seth, how old would Kim be?
I'm going off limb. I'm thinking 6.
You got it, okay. So the next thing we have to do is write an equation. They don't give us the equation for this one. We need to say that y equals something that's related to x. What did we do to x each time to get y?
You
added 2.
and then got something that like
So our equation,
Kim.
no, there's nothing in front of the x. Our equation is just, we take the x, we add 2. Whatever Carrie's age is, we just add 2, and that gives us Kim's age. Okay, so we have our equation, we have our table. Next we have to put together our graph. What are we going to put on the x-axis of our graph? Let's see. Here. Becca, what would you put on the x-axis? Yeah, who's going to go on the x-axis? Carrie's age or Carrie? Because we already decided Carrie was going to be x. So I'm going to write down here Carrie's age. But she's our independent variable. And then Kim's age. This graph is not labeled, so we need to label it. When you have to label a graph, you don't always have to go by 1s. You could go by like 5s or 10s, as long as you're consistent. So it's okay to have a different scale on each axis, but you can't go like 1, 5, 7. You can't just pick random numbers to put on your graph. They have to go in some sort of order, and it has to be the same amount. This graph, it's going to work to just go by 1s. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and the same for Kim. 1, 2, 3, 4, 5, 6, 7. So when Carrie was 0, Kim was 2. So we get that from...
Technically, Carrie would have been born.
Yeah, she would have been fine.
Right, the day that Carrie was born, Kim was 2. So we're going to put our first point right there. When Carrie was 1, Kim was 3. When Carrie was 2, Kim was 4. When Carrie was 3, Kim was 5. When Carrie was 4, Kim was 6. Now on the last graph, I did not connect the dots because I was talking about buying drinks. Could I connect the dots when I'm talking about age? Yes, age is continuous. You can be like 2 years and 1 day. So we will go ahead and connect the dots.
You didn't make her connect the dots in there, love them. They're so fun.
Most of what we do in here, you guys will be able to connect the dots. Okay, last thing that we have to look at is we're going to do a class activity where you're going to be matching tables, graphs, and equations. So let's talk about how to do that. So up here we have 2 graphs labeled G1, which stands for graph 1, and G2, which stands for graph 2. We need to decide which equation goes with which graph, and also which table goes with which graph. So my first equation is y equals 3x. That means whatever I put in for x, I have to multiply by 3 to get y. So I'm going to try some points on this. I'm going to try x equals 0. 3 times 0 would be 0. So when x is 0, let me just write some ordered pairs here. When x is 0, y would also be 0. And that's true on both graphs. So that didn't help me very much. Now I'm going to try 1. I'm going to say when x is 1, 3 times 1 is 3, so y would have to be 3. Now I'm going to go up to my graph. I'm going to look at my first graph. When x is 1, y is 3. So that point is on the graph. If I look at the second graph, when x is 1, y is not 3, because that would be up here, and that's not on the graph. So I know that graph 1 goes with equation 1. Okay? I'm also going to check the table. So on my first table, it says that when x is, that's 8, yeah. When x is 8, y is 4. Let's see if that would be true for equation 1. When x is 8, y would be 3 times 8, which is 24. So table 1 cannot go with equation 1. It must go with equation 2. So table, let's see how do I want to do this. Table 2, let's try table 2. Table 2 shows us that when x is 0, y is 0, which we already figured out. Shows us that when x is 1, y is 3, which we already figured out. So table 2 goes with graph 1. And then we only have one other one. Graph 2 is going to go with equation 2 and table 1.
Wait, there is another box.
I know, there's one more than we need there.
That's illegal.
Okay, your assignment, which you're not going to work on in class unless you finish the class activity, but go ahead and write this down so you have it, and I will start passing around the activity. For the activity, you are going to work with, let's see, I think we have enough in here, either pairs of 2 or 3.
2.
Two.
2.